So the next two examples from your booklet are a rectangular based pyramid and a cube. So you can see the base of the pyramid there is 12 metres by 10 metres, and they give us information in the question that tells us that the perpendicular height of the pyramid is 24. So from T to C, this perpendicular height here is 24 metres. So I'll just quickly sketch that in there. And what it's asking us to find is the size of angle TAC, given in the little purple triangle, and angle TBC, which is the angle given in the green triangle there. So basically you're going to have to do two calculations. And the idea is that if the T to C drops from the point of the pyramid down to the base of the pyramid, that it sort of falls right in the middle of that rectangle. So if I'm redrawing, for example, the little purple triangle, and I know A to C to T is the three letters that I'm talking about in the triangle, angle A is the one I need to find, and I know that the height of the pyramid is 24 metres, and I know that the base from A to C goes from the edge of the base to the middle of the base. So this little distance here is half of this distance here. So I know it's 5 metres. If I'm drawing the green triangle to calculate angle B over here, C is the bottom and T is the top. So again, I know the height of the second triangle is 24 metres, and I know that the distance from C to B is half of the distance of that front length of the pyramid. So I know that would be 6 metres there, and the angle I'm trying to find is angle B. So again, once you've actually got the diagrams drawn, we know opposite and adjacent in the first purple triangle, and we again know opposite and adjacent in the green triangle. So I don't think I need to actually do the working for that. It's really the diagram that is a little tricky in that one, to be able to visualize the triangles separately from each other. So once you've got those diagrams, I know you can continue with the calculations for that one. So I will move on to the final example, which is a cube. And I know it's a cube because of the little dashes on each side of the shape, telling me that every single side on that shape is 12.8 centimetres. So I need to keep that in mind when I'm figuring out where the triangle is that I'm talking about. So obviously at the moment this is a cube. We're doing trigonometry, so we're going to have to be finding a triangle somehow in this shape. And the question is asking us to find the angle of elevation from point A to point G. So if I'm drawing that in, it's basically the line that goes right through the middle of the 3 dimensions of that box. So the triangle that is going to be useful to me is sort of in 3 different dimensions here in the picture. So I don't have enough measurements from the triangle AGC. I'm going to have to do something else first. So I know from G to C is 12.8 metres. That's easy enough to see from the diagram. But the other 2 sides of that triangle I don't know anything about just yet. So it's going to be a 2-step process. If you can imagine this triangle at the bottom here, I'll just colour that in a little bit. You'll see what I'm talking about, I hope. So I know it's 12.8 metres from A to B, and I know it's 12.8 metres from B to C, but I don't know the distance from A to C. Okay, so if I start with that triangle, I would be able to do something. So if I redraw the triangle, and I'll label it so you can see what I'm doing. So I know from A to B is 12.8 metres. I know from B to C is also 12.8 metres. And A to C is a sort of an unknown length. If I can work out from A to C, that's actually the bottom length of the triangle that I actually want to work with. So the first step is to use Pythagoras, and x squared is going to be equal to 12.8 squared plus the other 12.8 squared. So if I solve that on the calculator, again, because it's not trigonometry, I can use just normal solve. Don't have to do numerical solve for just normal equations. Only if I've got sine, cos or tan in there, I have to worry about numerical solve. So the equation I'm going to be solving is x squared is equal to 12.8 squared plus 12.8 squared. And I'm solving that for x. So the distance from A to C on that triangle is 18.1019 ... And again, I'm not going to round until I get to the very end of this question. So now I'm looking at a different triangle, and I'll do it in a different color so you can kind of see what I'm talking about now. So the triangle I'm looking at now is the one that I need to get the answer from. So I already know 12.8, and now I've calculated 18.1 is this bottom one here, so 18.1019 and so on. So if I'm using that triangle now, I'm going to be able to get my answer from A to G to get that angle in here. Okay, so I need that angle of elevation from A up to G. So I'm just going to get rid of this because I haven't got enough space to keep going with the other bit of the answer. So if I redraw the triangle now, and I know that from A to C has a distance of 18.1019, and from C to, I'll put a few dots so I'm not actually rounding it to that many decimals. C to G is 12.8, and the angle A is the angle I'm supposed to be finding for an angle of elevation from A looking up towards G. So again, I've got an opposite and an adjacent, and tan again. So we use tan quite a lot. Opposite is 12.8. Adjacent is 18.10 ... And again, I'm not going to round it until I get to the very end of the question. So on my calculator, I'm going to do, because this is now trigonometry, I'm going to be using numerical solve, so 3, 6. And I'm going to be using tan. A for an unknown angle is what I would use. You're going to do a control divide to get your fraction template, and we've got 12.8 on the top of the fraction, the opposite side. And to get this adjacent side, the whole thing, with your calculator, if you put your cursor in front of the number that you want to highlight and double click it, you'll see it highlights the whole number. You will, unfortunately, to get it onto the bottom part of the fraction, you do actually need to copy it and then paste it. Okay, so you can do it, you can type it out, the whole lot of numbers if you want to, but if it's on the top line of the fraction, you can highlight and just hit enter. If it's on the bottom line of the fraction, unfortunately, if you hit enter, it still puts it onto the top of the fraction. So you do have to copy it and paste it if it needs to go on the bottom of the fraction. So we're solving it for A, and the size of that angle, or the angle of elevation to the nearest degree, would be 35 degrees. So I'll leave it at that, and hopefully you'll be able to do some work on that yourself tomorrow.